This is Precalc section 5.2, day 2 notes. We're going to start today by defining the reciprocal identities of the trig functions. First of all, whenever we're talking about terminal points on the unit circle, of course, we're always talking about ordered pairs that are of the form x, y. And now we know from our work with trigonometry and building those triangles in the unit circle that the x value of our ordered pair is the cosine of the angle and the y value of the ordered pair is the sine of the angle. So therefore, the sine of t is going to be equal to y. The cosine of t is going to be equal to x. And the tangent of t is going to be equal to y over x. Remember that cosecant is the reciprocal of sine. So cosecant is going to be 1 over y, which is going to be 1 over sine of t. Secant is the reciprocal of cosine. That's going to be 1 over x, which is going to be 1 over cosine of t. And cotangent, is the reciprocal of tangent, which is going to be x over y. So that is going to be equivalent to cosine of t over sine of t. We can also think of tangent t as, including y over x, we can think of that as sine t over cosine t. And so then we could think of cotangent as being 1 over the tangent of t. So you'll see as we use these in chapters 5, 6, and 7, sometimes it's convenient for us to think of tangent as sine over cosine. Sometimes it's convenient for us to think of cotangent as cosine over sine, but sometimes we want it as 1 over tangent. It just depends on what the goal is that we're trying to accomplish. The next thing we're going to do is take a look at our calculators. So right now, I want you to pause this video in a second, and I want you to set your calculator to radian mode. You can tell which mode it is in by the little screen at the top. You should see either a DEG or an RAD. So take a moment, pause, and set your calculator to radian mode. Okay, now that your calculator is in radian mode, let's calculate sine of 3.1. That should be 0.041581. Tangent of 0.53 should be 0.585917. Cosine of 4 should be negative 0.653. 644. Now the last one, be careful. Remember, cosecant is the reciprocal of sine. So you actually have to do 1 divided by sine of 1.2. And that gives you 1.072916. Next, we'll be discussing even functions and odd functions. We talked about even functions and odd functions back in section 2.4, I think it was. And remember, what we were doing in 2.4 is we were taking a given function and trying to figure out if it was even or odd. And what we did was we substituted negative x in for x in all locations, and then we simplified. And what we got was, if the function came out the same when we substituted in negative x, then the function was even. If the function came out opposite when we substituted in negative x, then our function was odd. And if it was neither the same nor opposite, then we would say it was a neither. Well, some of our trig functions are even and some of our trig functions are odd. The even trig functions are cosine and secant. And the reason that I have the quadrants over here where the trig functions are positive is I want you to help you kind of remember that cosine and secant are even in quadrant 4, and they are, or excuse me, cosine and secant are the even functions, and they are the ones that are positive in quadrant 4. So I just put that there as maybe a way to help you remember that cosine and secant are even, and they are positive in quadrant 4. Okay. All of the other trig functions then that aren't cosine and secant, which leaves us with sine, cosecant, tangent, and cotangent, all of those are odd. Okay? So our even functions, what that means is that if we plug in, and I'm looking right here, if we plug in a negative t for t, and we do the operation, what we end up with is the same value as the secant of positive t, right? So we get the same function back when we plug in negative t. The same with cosine. When we plug in negative t, we get back out cosine of positive t. With our odd functions, we get the opposite function. When we plug in negative t and do sine of negative t, we end up with negative sine of t. When we plug in negative t in cosecant, we get negative cosecant of t. When we plug in negative t in tangent, we get negative tangent of t. And when we plug in negative t in cotangent, we get negative cotangent of t. So those functions, they are odd. When you plug in negative t, you get back the opposite function. And it's a little bit hard for us to understand this now, but in the next few days, we're going to be graphing these 6 trig functions. And then I will be able to give you a visual example that'll show you why cosecant and secant are even functions and why sine, cosecant, tangent, and cotangent are odd functions. You'll physically be able to see that on the graphs. Now we're going to change gears a little bit. We're going to talk about the Pythagorean identities. These are based on the unit circle and the Pythagorean theorem. So let's start with the equation of the unit circle, which is x squared plus y squared equals 1. And that's because our circle has a radius of 1. So if we draw our triangle here, we know that our hypotenuse, or our radius, is 1. And we're talking about our angle t here. And we know that the x value is the cosine, and we know that the y value is the sine. So from that, and from the Pythagorean theorem and the equation for the unit circle, we get our first Pythagorean identity, which is that sine squared t plus cosine squared t is equal to 1. Remember, our y leg is sine, our x leg is cosine, so sine squared plus cosine squared equals 1. There are 2 other Pythagorean identities. They come from this original Pythagorean identity. Let me show you how to derive them. So if you start with sine squared t plus cosine squared t equals 1, and you divide every term on both sides of the equal sign by sine squared t, and you simplify, sine squared t divided by sine squared t gives you 1. Cosine squared t divided by sine squared t gives you cotangent squared t. And 1 over sine squared t gives you cosecant squared t. Now let's go back to the original Pythagorean identity again. Sine squared t plus cosine squared t equals 1, but this time we're going to divide all 3 terms by cosine squared t. So it's the same identity, but we are just changing the way it looks by dividing everything by a different function. So for this one, sine squared t divided by cosine squared t, sine over cosine is tangent. So that term becomes tangent squared t plus cosine squared t divided by cosine squared t is 1 equals, and then 1 over cosine squared t, that's a reciprocal, right? That's going to be secant squared t. These three Pythagorean identities are going to be our friends in chapter 5, 6, and especially chapter 7. Okay? You don't have to memorize them. It's great if you do, but if you can remember sine squared t plus cosine squared t equals 1, you can always derive the other two by either dividing by sine squared t or dividing by cosine squared t. So now let's look at examples of where we can use this information. The next example says, write the first expression in terms of the second if the terminal point is in the given quadrant. So for example 1, they want us to write sine in terms of cosine. That's what the instructions are asking us to do. I know it sounds a little weird. So write sine t in terms of cosine t. That's what they're asking us to do. And the fact that our ordered pair, or our terminal point here, is located in quadrant 1, that tells us in quadrant 1 that both sine t and cosine t are positive, right? That's going to come into play later in our problem. So I'm going to begin with the Pythagorean identity, sine squared t plus cosine squared t equals 1. My job is to write sine in terms of cosine. So I want to know what does sine equal in terms of cosine. So I'm going to solve this for sine squared t, which means I'm going to subtract cosine squared t over to the other side of the equal sign. So sine squared t is going to be equal to 1 minus cosine squared t. Now, just like any other algebra problem, if I want to undo something that is squared, I have to square root both sides. When I square root both sides of this equation, the square root of sine squared t is just sine t is equal to, and then I have plus or minus square root of 1 minus cosine squared t. Now back to the beginning of the problem where they told us that the terminal point is in quadrant 1. That tells us that the value of sine has to be positive. So we're going to choose for our answer, sine t is equal to the positive square root of 1 minus cosine squared t. We just wrote sine in terms of cosine and for quadrant 1. Our second example, they want us to write tangent of t in terms of cosine of t. And they tell us that we are in quadrant 4. Well, in quadrant 4, our x values are positive, right? So in quadrant 4, cosine is positive, our y values are negative, so sine is negative. If tangent is sine over cosine, then that tells us that tangent will be negative. Okay, we're going to pull some information from the answer to example 1. Remember in example 1, we found that sine of t was equal to plus or minus the square root of 1 minus cosine squared t, right? Although since we are in quadrant 4, we know that we're going to be using the negative part of that, okay? And then the other thing that I'm going to do is I'm going to write right here that tangent of t is equal to sine of t divided by cosine of t, okay? So that makes this process pretty easy for me. Basically, I'm going to jump right down to the answer. We're going to come back to this in just a moment. So I'm going to start by writing tangent t as the fraction sine t over cosine t. But if I'm supposed to write tangent in terms of cosine, that means that I have to replace my numerator with an expression where sine is in terms of cosine. That's what I did in example 1. So I'm